Here we derive the expression for the subtractor. Now what is subtractor? Output is difference of the input. So that is the subtractor. Now how to construct the diagram and how to derive the expression, now we will see in this lecture. So now here we are giving, subtractor means what? Two inputs we need to give, that we are giving to the two, inverting and non-inverting, for plus and minus. For inverting terminal I am applying the V1 voltage, and for non-inverting terminal I am applying the V2 voltage, and non-inverting terminal is I am also connecting to the ground like this, and inverting terminal a feedback resistor is connected. So from the output, so RF this now if I take these all resistor values are different, that time it will be little difficult to derive the expression. The length of the expression will be very it will go longer. So I will take this R1 and R2, and this also R1 and R2. Now if we take both the resistors equal and these two resistors equal, then that time the derivation will be very simple. So first let me explain the derivation, simple derivation, and later we will try to analyze the with 4 different values how the derivation look like. Okay, now here V1 is applied, V2 applied. So R1 both the resistor values are same, and here also feedback resistor value, and here this resistor value both are same, and V0. Now we need to apply, now here if I am assuming the voltage is VA and here it is a VB, we need to apply the nodal at A and also nodal at B. So VA, VB both we need to write. Now first I am taking the nodal analysis at point A, then I get VA minus V1 divided by R1 plus VA minus V0 divided by R2 is equal to 0. Now this is the expression for the VA. Now from this VA is equal to, and what is the first expression? VA is equal to VB. This is the expression number 1, equation 1. So this is the equation 2, and from this we will try to write VA is equal to what? 1 divided by R1 plus 1 divided by R2 is equal to V1 divided by R1 plus V0 divided by R2. So VA is equal to what can we write? VA is equal to R1 plus R2 divided by R1 plus R2 is equal to V1 divided by R1 plus V0 divided by R2. So now here from this VA is equal to what can we write? VA is equal to R1, sorry, in the denominator it is R1 R2. So R1 R2 divided by R1 plus R2 into V1 by R1 plus V0 by R2. Now this is for the VA. Similarly, we need to derive the expression for the VB. So VB is equal to what? VB directly you can either you can apply the nodal analysis, or using voltage divider also you can write. If I apply the voltage divider at B, VB is equal to V2 divided by R1 plus R2 into R2. This is the applying voltage divider. If you don't know the voltage divider, then directly you can apply the nodal analysis and you can derive the VB is equal to. Now VA is equal to VB, so that's why now I equate these two expressions, then I will get V2 divided by R1 plus R2 into R2 is equal to R1 R2 divided by R1 plus R2 into V1 by R1 plus V0 by R2. Now here denominator cancelled and R2 also we can cancel, then V2. Now here we need to write the expression for the V0. So now here if I am sending R1 to this side, so V0 divided by R2 is equal to V2 by R1. This R1 I am sending to this side, so V2 by R1 minus V1 by R1. So V0 is equal to R2 by R1 I am taking out. So R2 by R1 into V2 minus V1. Now this R2 by R1 is the gain, and if you see output is V2 minus, means what? The voltage applied to the positive terminal. It is the difference between the voltage applied to the positive terminal to the negative terminal. So V2 minus V1. So however you wanted to take the notation, so here no need to take always V2 to the positive terminal, whatever the notation you are giving. So forget about the notation. Now which voltage you are applying to the positive terminal. So positive terminal voltage minus negative terminal voltage into gain. If R2 is equal to R1, if all the resistors are same, R2 is equal to R1 is equal to R, then at the time what you will get, V0 is equal to V2 minus V1. Now this is about the subtractor. Output is the difference of the two inputs, that is nothing but a positive terminal voltage minus negative terminal voltage. So this is a subtractor. Now if you wanted gain, that time you have to take like this. So R1 both the resistors same, R2 both the resistors same. If the two different voltages are given and all four resistors are different, at that time how to calculate? The same. You need to apply the nodal analysis at B, apply the nodal analysis A, and derive the expression. So in the exam you may get the subtractor question, so with the different resistor values also. So process is same. Not only for the subtractor, for any application. So if the values are given, then how to find out the output means just apply the nodal analysis at A, apply the nodal analysis at B, and equate the two expression, then you will get the output. Now this is about the subtractor, and not only subtractor, and remaining everything, all the applications procedure is common. Only the difference is what? How to draw the diagram and how to apply the input voltages, that you should know. So this is the subtractor. That's why I have given the two different inputs for the two different voltages for the two different inputs. So this is also called as a difference amplifier. So with this we finished the subtractor. Thank you.